graphing. So what we're going to cover today is not only GraphQL. So GraphQL is the query language, which feels a bit like JSON. It's not really JSON. And then we're going to go ahead and look at a graph database and what are some of the benefits by putting your data into a graph. So when I say graph, this is not the graph that I mean. When I think about a graph, I think more about something that looks like this, with lots of nodes, lots of edges. Graphs are about math and graph theory, but you're not going to hear me talk much about math because I didn't get into this business to do math. Graphs are about data, big data, and how do we traverse that data? How do we get from one point to another in a meaningful way and find the things that we didn't know about when we first designed the data? So why GraphQL? GraphQL is the framework or the standard that's put forth by Facebook. And yeah, it really does help. Of those points there, I want to just have a look at the versioning. A lot of times people say GraphQL does not need versioning. If anyone has experienced that, I'd like to chat to you. Please come see me, because I find that I still need to do a little bit of versioning or at least give it some thought. But one of the biggest things for me is retrieving data only once. So think about if you had to go to the store, you're going to go out to Woolies, you're going to go buy something, you're going to bring it all the way home, take it out of your car, put it in the pantry, get back in your car, go over to Woolies, buy one more thing, bring it home, put it in the pantry, go back to Woolies. Not the most efficient way to do this, right? And when we think about calling APIs or REST endpoints, most of our overhead is sitting in making the connection. So why do we make the connection again and again and again? So as an example, if you were fetching a blog post, which of these would you want to do? I used to do the 11 request thing, and then I found out how to do the 2 request thing, and it wasn't long before I realized that the 2 request thing is not really a 2 request. You always need more on a page. It still becomes a 6, 7, 8 times you're doing requests. What I would like to do is I'd like to do the 1 request, 1 payload, encapsulates all my resources, I get them back once and I show the page, or my data, or my screen in my app, right? So let's take a look at what that looks like. Oh, and that's going to pop up every now and then. Oh, this is pretty cool. Has anyone seen this? This is a programming language in emojis. Not very useful, but interesting. Alrighty, so here I have a REST endpoint. It's a very basic REST endpoint. It calls person number 1, and I get this data back. This is me, and I have a list of friends over there. This is a typical REST endpoint, and I would love for my REST endpoints to look this clean. They don't always end up looking like this. I always have get the person / for login, get the person by age, get the person for something else, right? We always want to build these nice REST endpoints, but they end up being a nightmare. And you saw in the keynote this morning, Marco even mentioned, where do we, what did he say? He said, where we get the customer by year, not ideal for getting your data, right? So what if we could do something like this? What if we could do something like this? And we could go ahead and ask for a person. Our person ID is number 1. We're interested in the first name, last name, email address, and the friends of that person. And we could get back something that represents that person. Let's make that a bit something like that. So here I'm seeing me, and I'm seeing 2 of my friends. What happens if my screen changes over time? This is not what I want to show. I am now interested in some of my friends' friends, and their first names and their email addresses. So one REST endpoint or one endpoint has now given me a whole new outlook on my data. And I've controlled that from the query side. How awesome is that? Again, if we don't need a field, we'll go ahead and remove it, run that. I now no longer have the last name. Yeah, cool. It's all good and well that we can see something like that working. What does it involve? Well, to make an endpoint like this takes a bit of effort on the developer's part. You'll see any type of app over there. We've got some of these apps running on React. We use a lot of Vue where I am at the moment, Media, but they all boil down to writing a query. And the query gets written in GraphQL. GraphQL needs a schema, so we define a schema for our graph. That schema is made up of types, and every type has a resolver. So I'm going to give that a second to sink in, because we're going to have a look at how to implement this endpoint right now. And I want you to notice the types and the resolvers. Right? The resolvers resolve down to a service. That could be anything. We're going to use a bit of a REST endpoint. That REST endpoint I showed you now. Or you can go straight to your database. However you want to do that, it's up to you. The resolver is open for you to use. Alrighty, so let's have a look at how this looks. And how am I going to do this? I guess let's start with, I am going to delete my demo directory. Did I get that right? rm-rf demo. And let's go ahead and make a new directory called demo. And we'll start off with a nice clean slate. So you'll have a look here in my folder demo, completely blank. What we are going to need to do is we are going to need to install some npm packages. So I'll go ahead and install Express. I will install GraphQL, Express GraphQL. And because we're working with a bit of an endpoint or REST endpoint, let's use node fetch. And we have a basic app or dependencies for our app ready to go. What we can do, we'll start off this by let's go ahead and get some Express here into our app. And did I get that right? Oh, that's not working, that file. Okay. We installed those in the wrong place. Let's try that again. So it's always the risk when you do this live. But let's do a directory called demo. I will get this right. Am I already in demo? Oh, okay, cool, thank you. And we'll install those dependencies, and let's hope this looks a bit better. We have a demo, awesome. So what I'll do is I'll create an index file over here. And in this index file, the first thing we'll do is we'll go ahead and get Express. And then we will create ourselves an app. And we will tell this app to listen on port 3001. Then we'll go ahead and get a GraphQL HTTP, and that's going to come from our Express GraphQL. So all this is setup work just to get our app running over here. And we will create a new GraphQL HTTP, and we are going to tell it to use this thing called a schema. A schema is important because this is how we know what to call, right? We don't have anything unless we have a schema. So let's go ahead and create our schema, and I'm going to get a schema in a schema file over here, and that should be good. We'll then go ahead and create a new schema. And what we need over here is we're going to get some GraphQL dependencies. We'll start off with the GraphQL schema, and we're going to get that from the GraphQL library, and that is not going to work, so we'll try that again. And we will go ahead and export our schema. So we'll export a new GraphQL schema. And as part of the schema, we will tell it that we are interested, as for our queries, we want some sort of a query type. Now remember we said that, that we are going to have to define some types. So the first type we're going to define is our query type, and we're also going to tell us here that we are interested. Actually, you know what, let's not do this here. Let's do it over on this side. As well as a schema, I am going to tell Express that I'm interested in this thing called GraphQL. Now GraphQL is a developer tool that helps us explore the graph. Right? It's the one that you saw me query in over here. GraphQL is available in most languages libraries. We use this in our Ruby apps, we use this in our Django apps. All of them simply hook into the frameworks that you're using, and you get this nice, easy to use, discoverable bit for your graph. Alrighty, so let's have a look at what this query type might look like. So we'll go ahead and create a query type, and that is a new GraphQL object type. And this definition for an object type, or the API for the object type, is always the same. It always has a name of some kind. In this case, we will call it query, and it has an optional description. And I'm not too worried about the description today, but it is pretty useful when you're starting to debug some of these graphs. You want to know where you're going, why you made this, what it's doing. Then we'll go ahead and we'll define some fields. And the fields we'll need is, we had a field called person, and that person was of type graph. Actually, you know what, let's make it a person type. And even though we don't have that person type yet, we'll get to it soon. The other thing we will need is we'll want to load up a person based on some sort of args. We will give it an ID as our args, and that ID is of type GraphQL string. We then mentioned that we would need to have a look at some of the resolvers. So we're going to tell this query type how to resolve a person. And to resolve a person, we give it a function. And over here, what we would do is we would return anything that is, has the interface for a person. What we can also do over here, though, is we can send back anything that is a promise of type person type. Now this is huge. Being able to return a promise in this case means we can do almost anything we wanted to do. So if that meant going ahead and calling and sending a text message to somebody that we know, and then doing something else, and then eventually going ahead and returning our person, we can go ahead and do that. That's not very useful for us today, so let's have a look at what we can do. We have that REST endpoint that I showed you earlier. Let's see if we can use fetch to call that. So we are going to go ahead and ask fetch to fetch something on some base URL, and we sort of know where our service lives, so we can go ahead and define our base URL. We'll set that up as, and that's going to get really annoying. HTTP localhost 3000, that's where that lives, as well as then into person, and over here is where I can make use of those args. So I can say, and the args ID. So if anyone asks us for a person, we'll go ahead and find the ID in the args, pass it through to our URL. We will then need to get some sort of a response, and we will just go ahead and pull out the JSON. Now I'm a pretty good fair developer, I feel, so I'm going to think about the next developer in the line and pull this out a little bit and call this get person by URL. Let's just make it nice and easy to read, and I'll go ahead and define that over here. And that's going to take in a relative URL, and we will just return our fetch and make sure that we use that relative URL over here without that. And so we should be able to just get our person still based off of our argument, and that should look good. So I think at this point we've got a pretty good query type. We can query the person by his ID. We know how to resolve it down to get some sort of data back. The only piece of the puzzle missing right now is this person type over here. Let's go have a look at what that would look like. So if I go ahead and create the person type, again, this is a new GraphQL object type, and we should be recognizing all the properties for this one, or the API for this one, right? We have a name. I'll call this one person. We have a description. Not going to worry too much about the description. We have some, and then we have some fields. And we're going to define those fields as all the fields we saw in that query. So the first field we had was called first name, and first name had a type, or is a type of GraphQL string, and it's because, okay, so if you noticed on my API over here, I'm getting first underscore name and last underscore name, and that's not really what we queried. We queried first name and last name. So this is where we have the opportunity now to resolve within the object any properties that might sit there. So we will go ahead and resolve first name, and we'll get in the person. So the first argument to the resolve is always the root element. In this case it's the person, and then it would be something like the args. And I just noticed I missed the root element here and the args, so that we can use args in that expression over there. So once we have the person over here, we can go ahead and just say, okay, return person dot first underscore name, and that looks good to me for a first name. And go ahead and do the same thing for the last name. And then when we have a look at something like the email, because we don't have anything special about the email field, I don't feel we need to resolve anything over there. We're just going to go ahead and tell it that it is a GraphQL string, and it'll use the same name. We can do the same thing for the ID. And now we get to the interesting bit. What about this property called friends? How does that look? Well, friends has a type of GraphQL list, and I better make sure I get a new one of these, of person type. And we will go ahead and tell it how to resolve one of those. So again, we get the person, and if you have a look at our person's friends, go back, let's shift over here, you'll notice that our friends is really just an array of strings that represent the URLs to get my friends from. So I should be able to just map those into get person by URL, and that should help us get our friends. So always the scariest part of a demo like this is making sure that everything runs live. So let's quickly make sure that all of these types we used the GraphQL object type, we've got that. We used the GraphQL string, we have that. We used a GraphQL schema, we've got that. And we used the GraphQL list. We've got that. Last dependency that we would need is to make sure that we have fetch. And we'll just get that from node fetch. And we should have a running demo. Okay, give it to me. Oh, is it? Line number? 32. There we go. Well spotted, guys. Saving me here. And it ran first time. Well done. I'm going to call this your demo. All right, so we started that up. It's running on port 3001. We'll go ahead and refresh port 3001. So 3001. And that's not too good. Yep, that's a problem. Probably have to tell our app to use one of those. That does not look right. Alrighty. Give that another go. And there we go. So we have GraphQL up and running. We can go ahead and write this query. I'll write this one with you so you can see what we get from GraphQL. Because we're typed, we now get syntax or suggestions. We can see we have a person. Person has an ID of 1. We're interested in the first name of that person. Oop, what am I on here? Perhaps the email of that person, their friends, their first names, their email, their friends, their first names, their email, and we can go on and on and on, and you can build any query you want at this point. So as long as you have the types defined and you have the resolvers in place, you can have the query decide what to bring out for you. Cool. So, one of the things you'll notice if you have a look at this kind of looks like JSON, but without some of the commas and so it feels almost natural. So if you have, once you get used to the syntax, very easy to use, because it's almost as if you're asking for exactly what you're expecting. So if you think about what you want your result to look like, put that in the query, and it'll come out on the right-hand side pretty much how you expect it to from the left. And that's GraphQL. GraphQL has a few extra bits that I'm not showing over here, things like mutations, so it also supports putting data in as well as out. They're a little bit more defined, like you do a bit more work to get data in. I find that very often I still use my REST points to get data in, so the REST service doesn't go away, but I get a lot of benefit from the query on the other side. That said, you could probably do everything in GraphQL and you won't need the REST endpoint anymore. It could become your API. Cool, so that's GraphQL. Let's have a look at graph databases. Now, as scary as that demo was for me to do, it's more scary to talk about something that's not SQL. Because standing up here and saying something about SQL means that I am probably going to lose some friends. I'm going to get trolled over Twitter. My Facebook account's going to get all filled up. But here we go anyway. Some of the things I find with SQL, and are these. So the ones, I think the first three are pretty self-explanatory. SQL being pretty simple, like if we admit it to ourselves, SQL is actually very simple, right? You select something, you filter for something with a where clause, you order it by something, and you limit some results, and you've got some data, okay? The fact that SQL is really simple means that it puts a lot of work in the developer's hands, right? More work for developers means more things can happen, more difficult conversations that need to be held. What if we could speak about what we want to get from our data in the terms of our data? So like Marco mentioned this morning in DDD, what if we have this ubiquitous language that followed all the way through to our database? And when we speak about our database, we speak about the things in our database and not the structure that the database is in, right? So as an example, this is discussions we've had in our office. We're not drawing tables anymore. We're drawing things that represent people and places and things, and the relationships between these peoples and places and things. What do these relationships mean? And that's mostly where we get the benefit, because it's not really in the thing, right? And I think Marco showed that so well this morning. It's not the noun. It's the other things around it that mean so much more. So let's have a look at what a graph would then look like. So you've got this idea of a vertex or a node and an edge. Now I promise that's the last time I'll mention math today. We tend to think about these more in terms of entities and relationships. So A and B are two entities, and the arrow between them is a relationship. And that relationship goes in a direction. So the arrow has, or the line has an arrow attached to it. Entities can have relationships with entities that are the same kind of entities. So for example, Peter can be the son of Paul. They can also have relationships with entities that are not the same as themselves. For example, Peter lives in Johannesburg. Everything in a graph has a label. So here we're seeing a product that was bought by a customer. The node, the relationship, and the other node all have labels. And everything has properties. So when you think about a SQL table related to another table, it feels pretty familiar, right? But we always end up doing these things where we create this intermediary table that holds some piece of data that doesn't really belong in the product, it doesn't really belong in the customer, because it was context specific. It was at the time of the customer buying this product that there was meaning. So in the graph, everything gets properties. So here, for example, it was bought on the 12th of April. And it's a Spider-Man lunchbox that was for $8. And was bought by Jack, age 12. This is what a graph, so the database I'm going to show you today is called DGraph. And DGraph uses GraphQL as its query language. Sorry, let me say that again. It uses GraphQL+. So it looks a lot like GraphQL, but they soon noticed that there's some things in GraphQL that you just couldn't do when you have nodes and relationships. So they took the GraphQL spec and they built a few functions on top of the GraphQL spec. And that's why you're seeing that func in the middle over there. And that allows them to do a lot more powerful things in the database that you wouldn't normally be able to do over an API or something you'd want for just straight data out. So this query is selecting a product, the Spider-Man lunchbox, getting its name, its price, when it was bought, by whom. What is their age and their name. So notice in here, I don't have the word table, I don't have the word join, I don't have a filter. It's all in the domain language that we speak about, right? So I can map this one-to-one with the conversation I'm having about the business. And I love that about graphs. So let's have a look at a database, a graph or DGraph. So DGraph is a graph database. It has a very similar UI to GraphQL. It looks something like this. And I can go ahead and write almost the same query. Right? I want me. I'm going to tell it that I'm going to use a function for equality across my ID of 1. And I'm going to go ahead, and from here it looks the same, right? Except that underscores are not mapped because I've designed the data in underscores. So first name, last name, email. I'll go ahead and run that. And the default view of DGraph is to give you pictures, right? Something that looks like a graph. This is me. But under the covers, it really is giving you back JSON. So same deal. The query that I sent to the graph is the query that came back. I can go ahead and expand that again across my friends. So the relationship is friend, and I want my first name of my friend and my email of my friend. I'll go ahead and run that, and I start seeing me and my 2 friends. I also see that coming back as the JSON I expect. So I get the same benefit as I do from GraphQL or from my GraphQL right in my database. It does, however, mean that I need to give it a bit more attention when getting the data in, right? Getting the data in a graph world is called a mutation, and a mutation, like it says, is just going to change something. So you're just changing data into the database. Yeah, I can quickly show you what that looks like. Up over here, I have a Docker container that's running my DGraph. What I'm going to do is I'm going to kill the container. We'll start up a new container. Docker compose down. And Docker compose up. So right now what I have is if I go back to DGraph and I run this query for you again, I'm not going to get any data, right? We're sitting now with a blank database with nothing in it. The first thing I need to do with this database is give it some sort of a schema, right? Same idea as when we did the queries or the setting up the schema for our GraphQL. We're going to go ahead and find an example of a schema because I'm definitely not typing that one out for you. So this is what a schema would look like. It's really just giving types to the system, saying when I speak about a first name, I mean this is a string, and then we're telling the database to index those as terms and as full text, so that we can then query these back out. So we get all the full text searching from the database itself. Again, emails are strings, IDs are strings, etc. Friend is this thing called a UID, and that's the internal IDing system for nodes. So I'll go ahead and run that on the database. What we do is we tell it that we don't want to explore the schema. We're going to alter the schema. So I'll go ahead and run that in. It says done, thank you very much. And then we will go ahead and do some mutations. So what the mutations are doing is it's setting data, right? So this little syntax up here with the underscore colon me, this is a variable defined only within the mutation, and once the mutation has run, it disappears. But it gives me the ability to relate things to each other. So up here you're seeing me defined with my ID, my name, and my email. Then I'm defining a couple of my friends. And then as I come down here, I'm starting to define me with the relationship of friend to Twain and to Andre. So now and then lastly, you're seeing that little dot over there. Those are the properties on the relationship. So in this example, I'm not giving any properties on the relationship, but I can. So let's go ahead and run that in. We'll go ahead and just mutate the database there. It says done again, and let's go ahead and run that query again, and we're starting to get data. Cool. So 101 DGraph, I think it makes sense. Here's an example of Stack Overflow thought of as a graph. It gets a lot more complex, and like I said, graphing is for big data. We're not scared of data in a graph. Because we start at one node and we traverse out, we find that getting huge lists of data is not something that happens. Even though you'll see in this example, there is quite a lot of data. I mean, we're mapping posts, relationships to posts, versions in posts, comments, upvotes, downvotes. It's all in there. This is the screen that we're going to query for. There's a lot of numbers on here. There's a lot of info, a lot of aggregation happening. And then as well as that number on the right-hand side there, the 299, the 163, is the score for the result in the query. This is how we order the query. So we get the best results up at the top. Let's have a look at what this query could look like. And get rid of that box again. So let's go queries. Okay, hold on. Before I scare you with this query, right? Let me show you a little bit of a simpler one. This is one that we would probably use to query for a simple home page where we wanted maybe the logged in user. That's the first person that you're seeing over there with his first name and last name. And some of the news items that are relevant to him. We're saying, give me the news, limit that down to 10. We want the title, the expert, the created date, and then we want the author, right? So our data here is not that well defined. I probably would have said, instead of calling that person, call that author. Like have the relationship be author so that it makes sense and it reads in the business language. All right, are you ready to be scared? Not so bad, right? When I think of this type of query in SQL, I think of pages and pages of SQL and many different store procedures happening or views being called and layers upon layers of things to do. Over here, what we're doing is we're asking for any type question that has an answer, count the upvotes and the downvotes. Right? It reads simple, it means what it says. And then the important thing there is the score, right? So the idea of functions in the database itself means that we can do things like this. We can go ahead and do any sort of math calculations with the math functions, aggregations, the counts, the sums, etc. And that query alone produces that page that we had. Where is it? That one over there. Cool. DGraph is not the only graph database. There's a lot of other ones out there. OpenCipher is the query language for a database called Neo4j, and that's the one that you've probably heard of a lot. Anyone here use Neo4j? Cool. It looks hectic, and like Brendan over there reminded me last night, is that I should not be trying to write Neo4j queries live in a presentation, and you can see why. It is a little scary and intimidating. And then at the bottom, you're seeing the example of GraphQL. GraphQL has really simplified things for graphs and made our lives a lot easier. One more thing that I'd like to show you about the graph, or at least about the tools we have for the graph, is that if I'm not too sure about what my graph looks like, I can always go ahead and ask the graph for that. So I'll ask the graph for the friends relationship and give me the predicates available for the friends. I'll go ahead and run that, and we're interested more in the JSON in this case, and that did not happen because there's no such thing. It's friend. DGraph does have the idea of aliases, so you can go ahead and alias out friends for friend. We'll go ahead and get those. What I'm seeing now is I'm seeing the list of all the fields that are available to me for my friends. So the graph is explorable, right? We don't need heavy documentation for a graph because you can explore the graph. And that, I think, is one of the biggest reasons why people say the graph doesn't need to be versioned to stay in line with our documentation, etc. Similarly, in graphical, we can ask graphical. So graphical is a little bit different, or the GraphQL that we defined first is a bit different in that we do have to ask it for schemas and types, and then it will go ahead and return the data or all the information about our schema, the types we have, the fields we have available. You do have to ask for them. So we're getting type, name and description, and you recognize those properties from the implementation I did. We have fields there as well. Yeah, so again, graph, explorable, I think it's a very nice thing. So I think I've covered enough about graphs to allow you to put it in your toolbox. I've put a few links up there for you to check out, and that's my Twitter handle. Is there anything that I can answer about what you've seen today? Any questions?
Sorry. So you've shown us the example of how your query contains a subquery, for lack of a better word, of the friend, and then a subquery for the friends of that friend.
Yes.
Have you got a way of traversing an entire tree all the way to the bottom or to the top, bearing in mind this is not a tree, it's a graph, there might be circular relationships. Can you do that in the query itself?
You can. You can ask the graph for any node that is X number of hops or unlimited number of hops from your node that matches your criteria. Yeah. So you can do that at multiple levels as well. You can ask the graph for your node and go one jump away might match your criteria, or 10 jumps away might match your criteria, and bring it out for you in one list. That was a really good question. Thank you.
How well does it scale? Not sure if they all have the same scalability to show the same. How well do the graph databases tend to scale?
To scale. So I guess it's a little different for every graph database. DGraph has been built to be distributed and transactional. Overall, graphs are meant to handle very big data. So you're looking at way more than you would start feeling a problem in SQL with. Yeah. We tend to use the graph as a querying mechanism. So Marco in his keynote this morning mentioned event sourcing and CQRS. Most of our systems are done that way. And one of our projections we go out to is the graph. And we project out to the graph 4 queries. And we find that the graph just grows really huge and running the queries in fractions of time. I have one here if you want to see it afterwards, where we've put in a movie database of, I think it's over 1 million records, and it's querying that out in milliseconds. Yeah.
So in your experience, for those of us who would then look to start creating these graph databases, what would be some key points, for example, that we should keep in mind when thinking about the actual structure versus like a relational database?
I think one of the hardest things for my team to switch was the language we use in discussions. We as developers tend to translate everything to tables and rows. And like that quote said, we're all SQL developers. Once we started speaking in objects that mean something, we found it very easy to start creating the graph. Before that, we struggled because the mindset was always table, row. And for example, we had a scenario where we did security. So we wanted users to be able to access certain things, and immediately the first thought was a user, right, or a permission for a user is a node. Is it really a node? We ended up going, no, it's not. It's a relationship. It's a relationship of the user to some piece of the system. And if the relationship was there, the user had the permission. So we ended up not or not representing a permission as a node, but as a relationship. So yeah, those are the types of things.
What you're showing here with your web service and the query goes through it, that's now
Grab that one there.
what you've been showing here with your web service and the query, that would now replace what traditionally would be your SQL connection string between your application server and your database? Or are you exposing these things directly?
Yes, you could
publicly?
you could certainly do it that way. At the moment, because we have a lot of REST services already available, we're building on top of the REST services. But definitely, you could go straight to database, and instead of doing SQL connections, create the schema and rather query the schema. Does that help? So where would you? Let me put it another question. Where would you put the SQL connection string?
On an application server
Okay.
that enforces permissions
Yes.
and sort of a layers of access control between the user and your data store.
Awesome. So yes, if I go back, let's jump back to over here somewhere, and we have a look at our schema. So over here, I'm doing the get person by URL. This is calling the service we had. But if you were going straight to your database, you would probably be getting something like, and I hate to do this after Marco's talk today, but it might be getting something like a person repository. And I only put that word in for you right now so that you know it's a repository. I do agree with Marco. I don't like that. But you might have that repository, and that repository might hold the SQL connection, right? And then up here, instead of doing this, you would be going, okay, well, my person repository, dot find, and I'll go ahead and find all my people. Brendan.
Cool. So my question is just more on the mutate that you had there. There was like a typo with the friends that you had, and it just said done, and there was no issue or error. So how do you like enforce integrity and make sure things are working the way you want them to work?
Okay. Let's see if I can find the typo, and then somewhere in here.
Yeah, just scroll down a bit. Yeah, there, line 27 and 28.
Yeah, okay, so that's not really a friend.
So that query just ran and it didn't give any warning or...
Sure, so the DGraph is a NoSQL store. So it stores things as documents. So it's not going to do any type checking for you there. What it is, it's just going to create a new relationship called friends the wrong spelling. And when you query that back out, you're not going to get that result. So it's not going to replace anything you do, like tests over your system. You still need to do those. With that incorrect, though, any of the indexing is also not going to work on that relationship. Yeah, so still very much in your hands to make sure those mistakes get caught by unit tests or integration tests, things like that.
Okay.
Cool. Yes.
Just one question from my side. DGraph, how does it compare to, for instance, having a Hive or having a Hadoop stack for that?
So DGraph is distributed, but DGraph is not, what's the query, the Lucene, it's not a Lucene index. So you're gonna write different types of queries for the graph. For example, it's definitely not a replacement, right? It's a different way of thinking about the world, and you're answering different types of questions. A huge data store like that, you might ask the question differently. So when you're looking for people who bought products, that bought similar products that were from the same manufacturer that were also a small lunchbox, that query is a lot easier to ask in the graph than you would in another store. That said, it's not a replacement. Like I said, when we project out, we project to the graph, but we'll also project out to Elasticsearch and to a bigger, searching system, and use the tool for the right reasons. But for those types of queries where you want to know X number of nodes away from you, and you don't know that for sure, it's a variable length query, the graph is really good. I always think about it as if it's your GPS navigation system works really good on a graph. I want to get from point A to point B. I know about the 2 nodes. Work out which is the best way to get there. Cool. Why are you staring at me? Okay, sorry.
It's lunchtime now.
Okay, you guys are so awesome. You're sticking
Come
around.
talk
Do
to
you want
you
to hear
afterwards.
another question? Sure thing. Thank you very much, everybody.